In this short video, I'm going to show how to capture traffic, UDP traffic, using tshark and display the contents using JGroups. So the cluster we're going to be running a cluster of 3, is A, B, and C. Here's the configuration. The bind address is loopback. That means we're going to bind to 127.0.0.1. The bind port is 7,800, which means the first member is going to run at 7,800, the second at 7,801, and the third at 7,802. The multicast address to be used is 228.222. Let's run tshark. Tshark is the command line version of Wireshark. Tshark, we're going to be listening on interface loopback 0, because all the traffic is going to go through this interface. Then the expression to be used is UDP. We want to capture UDP traffic, not TCP traffic. And we want to capture traffic going to and from port 7,800 to 7,802. So the filter expression to be used here is a port range 7,800 till 7,802. This needs to be piped to an output file that we can then read using JGroups. Now, this will capture the entire traffic. This will capture all the UDP packets, including the IP packets. We don't want that. We're only interested in the data part, which is where the JGroups messages reside. So we need to add a command line option T fields. We're interested in the following fields, namely the data section. So let's run this. This is capturing packets now on loopback. Then we're running A. This is the first member, the coordinator. Running B. And we're running C. Okay, the view is A, B, and C, and we're sending a few packets on B. Then we kill C. Should take a few seconds, and we should see a new view that's consisting only of A and B. Here it is, and now we're leaving B and leaving A. This is just a short demo of 3 members, and the traffic that was captured consists of 95 packets. So let's kill tshark, and let's look at the contents of the file temp.dump. This can be done using a class called parse messages that shipped with JGroups. So org JGroups tests parse messages. The command line option -file looks basically reads the contents of a file and displays the contents as JGroups messages. So we can see we have 95 packets, and let's look at the contents. The first packet is a discovery request from A to everyone, get members request. This will not succeed because there's no other member. So A will become the coordinator. And then the second one is from B to A. It's also get members request. At this point, A sends back a response to B, namely a get members response. That's a discovery response. Then B knows that A is the coordinator and subsequently sends it a join request. A now multicasts the new view, which is AB, to everyone, and it also sends a join response back to B, which also consists the new view. The multicast coincidentally is discarded by B, but the join response containing the view is installed. Now C does the same. We're not going to look into this, but here we're seeing that we are sending around heartbeats. This is because we defined FD_all to have a timeout of 8 seconds and everyone sending heartbeats at every 2 seconds. If you don't get a heartbeat from a member, that member will be suspected and excluded. That's what is going to happen to C later. Here we see A sends a heartbeat to all, B sends a heartbeat to all, C sends a heartbeat to all, and so on and so forth. At this point, B was sending around messages. You can see it always sends the message to everyone, so-called multicast message, sequence number 1, 2, 3, up to sequence number 25. At this point, we killed C. So here you can see this is the last heartbeat that C sent. And at this point, we're only seeing heartbeats from A and B. And here, A basically suspects that C is dead and sends it a verify suspect message, are you still alive? C is not going to reply, and at this point A creates a new view which consists of A and B, showing that C left. The next view is B leaving, which is down here. So A sends a message to all with a view that says B left. This is one way of capturing traffic. We can also run tshark, and instead of piping tshark to a file, we can pipe it to parse messages directly. And this way we can look at traffic interactively. So now it's capturing traffic like before, but it's piping its output directly to parse messages. We can see if we start a few members that oh, there's one flag I forgot here. It's actually the -L, which means packets are not buffered by tshark, but displayed immediately. So you can see we're starting a few members, and you can see the traffic is shown immediately. All right, this concludes our small demo. Next up, TCP.